All right, so my next question is, what is the displacement vector for the trip for the rabbit? Let's suppose, what's the displacement after 15 seconds? So say from 0 seconds to 15, what's the change in R? So if we look here, we've got our change in position vector, the displacement. And we know that, well, it's where we end up minus where we started. So those are our two position vectors. Well, we just figured out what the final position is. Didn't we figure out that R2 is 66 meters in the I minus 57 meters in the J? We just figured out what R2 is. So from that, we've got to figure out where was our starting point? Well, duh, you think it's going to be at 0 and 0. Well, guess what? Not so. When we look out the window and see the rabbit, the question is, where is the rabbit located when we start out at 0 seconds? So we put a 0 here, 0 here. We find out this term cancels, this term cancels. Well, hey, the rabbit's at 28, right, which does not cancel. So if we look here, and the initial position of the rabbit is 28 meters from where I'm looking in the eye. Looks like that. And then same thinking here. If I put 0 time here, 0 time here, these two terms cancel. Whereas the rabbit at 0 seconds, it's not at 0, it's actually at 30 meters in the J. So if I'd like to figure out what our displacement vector is for this trip for the rabbit from 0 to 15 seconds, what's its displacement? I've got to take R2 minus R1. Well, let's just go ahead and do that. So we've got 66 meters in the I here, minus 28 meters in the Y here, in the I here, and that's 38 meters in the I. There it is. And if we look here, we've got negative 57. This is going to be tricky. Minus 30. A minus from the 57, we're going to end up with negative 87 meters in the J. So the bottom line is, for our change in R, our displacement vector is going to be 38 meters in the I, 87 meters in the J. I'll leave it up to you to solve this, but if we look here, we can actually figure out the length of the change in R vector, the displacement vector, so we know its magnitude. And we can also figure out what the direction is, what the angle is for this particular vector. So go back, punch those in your calculator, use the Pythagorean theorem, get the magnitude, and then the final direction. I caution you, you know the direction. When we get the final direction for the change in R vector, notice that it's 38 going to the right. We've got 87 heading down. You better give me an answer for the number of degrees here, somewhere between 270 and 360. Be very careful with that.